KNO3 treated with H2SO4. Sodium nitrite or potassium nitrite is treated with H2SO4. So that is NaNO3 treated with H2SO4. KNO3 is treated with H2SO4. So it is NaHSO4 plus HNO3 and KHSO4 plus HNO3. NaNO3 or KNO3 treated with H2SO4. So sodium bisulfate, potassium bisulfate and HNO3 are formed. Okay. Okay. And second, commercial preparation is a Ostwald process. Commercial preparation is a Ostwald process. So what is the commercial preparation of nitric acid is a Ostwald process. Commercial preparation of nitric acid is a Ostwald process. Okay. It involves 3 steps. It involves 3 steps. It involves 3 steps. Okay, so first step is a catalytic oxidation of ammonia. Catalytic oxidation of ammonia give nitrogen oxide oxidized in the presence of a catalyst, that is platinum or rhodium catalyst at Okay, but here ammonia is oxidizes to give water NO. So what is NO? Is a nitric oxide. And second step, NO oxidized to give water NO2. So here NO plus O2, it gives NO2. But first ammonia is oxidizes to give water NO. Second step, NO oxidizes to give NO2. Third step, NO2 is absorbed by water. So here H2O gives HNO3. So there is a small amount of what also formed, NO also formed. This NO can be recycled to the process. This NO can be recycled to the process. So here NO can be recycled to the process. So what is the Ostwald process involve? 3 steps. What are the 3 steps? Catalytic oxidation of ammonia gives NO. NO oxidizes to give water NO2. NO2 absorbed by water gives water HNO3 and a small amount of NO. This NO can be recycled to the process and can be concentrated up to 68%. So what is the laboratory grade of HNO3 is 68% by mass. Okay. ഇവിടെ 500 Kelvin ആണ് നമുക്കുള്ള ടെമ്പറേച്ചർ. 500 Kelvin. Okay, but catalytic oxidation of ammonia gives what? Nitric oxide. Nitric oxide oxidizes to give what? NO2. NO2 absorbed by water gives what? HNO3, and there is a small amount of water NO formed, recycled to the process and concentrated up to concentrated up to 68% by mass. 68% by mass and concentrated up to 68% by mass. Okay, it can be concentrated up to what? 98% by dehydrated. So what is the strongest dehydrating agent? H2SO4. Okay, so it can be concentrated up to 98%. It can be concentrated up to 98% by dehydrating with H2SO4. H2SO4. Okay, so these are the preparations of HNO3 nitric acid. So what is the commercial preparation of nitric acid? Ostwald process. Properties. Colorless liquid. Properties. Colorless liquid. Strongly acidic in nature. So what will be the dissociation constant of acid? Will be dissociation constant high. Dissociation constant of acid will be high. Okay, neutralize bases. Okay, so HNO3 oxidizing acid or non-oxidizing acid? Oxidizing acid. So why is oxidizing acid? Decomposes to give nascent oxygen. Strongly acidic, it is a strong oxidizing agent. Strong oxidizing agent due to decomposes to give nascent oxygen or monoxygen. Okay, that is 2HNO3 gives H2O plus 2NO2 plus monoxygen. Okay, so it can oxidize water C into CO2. So CO2 means C plus water 2 monoxygen. C plus what? 2 monoxygen. So how much monoxygen is required? 2. So how much HNO3 is required? 4. So what is the reaction will be? That is C plus 4 HNO3 gives 4 NO2. That means this reaction into 2. Okay, so 4 HNO3 gives 2 H2 and 4 NO2 with 2 monoxygen. So these 2 monoxygen combines with 1 carbon gives CO2. Okay. Okay, so it can oxidize I2 into what? HiO3. I2 into what? HiO3. So how many iodine here? 2. So how much 2 HiO3 should be here? 2. Okay, so here H2O plus I2 plus 2 into 3. So how much oxygen is 6 oxygen. 1 oxygen present where? Water. So how many monoxygen should be here? 5 monoxygen. Okay, 5 monoxygen. So how many HNO3 is required? 10 HNO3 is required. So what will be the equation? I2 plus 10 HNO3 gives what? 2 HiO3 plus. How many NO2 will be there? Water? 5. 1 H2O is present at 2 HiO3. So remaining here 4 H2. Okay, that means this 2 HiO3 means combination of what? 1 I2, 1 H2O and 5 monoxygen. So here we have 5 monoxygen, 1 H2O and I2. Okay, so 5 monoxygen is used here and 1 H2O also used here. So what is the remaining number of water molecules? 4 H2. Okay. Balance this equation. It can oxidize S8 sulfur into H2SO4. Balance. S8 into H2SO4. From this idea, first we know it can oxidize water H2 into HiO3. So how many iodine here? 2. So how much of 2 HiO3 or HiO3 should be here? 2. So how many water? 2 hydrogen. How many water? H2O and 2 I, that means I2, and 2 into 3 6 oxygen. So that means how many monoxygen? 5 monoxygen. That is 1 oxygen is with the H2. Okay, so the same way balance this equation. Okay. So how many H2SO4? 8 H2SO4. So that means how many water? H2O plus S8 plus 8 into 4, 32. 32 minus 8, 24 mono-oxygen. So how many HNO3 is required? 48. So that is S8 plus 48 HNO3 gives 8 H2SO4 plus 48 NO2 plus how many water? 24 water minus 8 water. So it is equal to 16 H2. Okay. Okay, it can oxidize P4 into H3PO4. Again, 4H3 present here, 6H2O plus P4 plus 10 mono-oxygen. So how many HNO3 is required? 20 HNO3. So that means P4 plus 20 HNO3 gives 4 H3PO4 plus 20 NO2 plus 20 HNO3. How many water? 10 water. And out of 10, 6 are present here. So what is the remaining number of water molecules? 4H2. Okay, so HNO3 act as a good oxidizing agent due to it decomposes to give water nascent oxygen. So it can oxidize water carbon into CO2 like I2 into HiO3 and S8 into H2SO4 and P4 into H3PO4. So this is the balanced equation. Okay. Okay, next one. Reaction with the Cu and Zn. Reaction with Cu and Zn. Reaction with the Cu and Zn. Copper and zinc. Okay, so that is a C and Z10 plus HNO3 and Z10 plus HNO3. So we diluted HNO3 and concentrated HNO3 and diluted HNO3 and concentrated HNO3. So what are the product formed when copper is reacted with the diluted HNO3 and copper is treated with the concentrated HNO3? The same way, what are the product formed by zinc reacted with the diluted HNO3 and zinc reacted with the concentrated HNO3? So HNO3 is strongly acidic in nature, so most of the metal can dissolve in water, HNO3. So what will be the product formed here? Cu NO3 twice. Here also what is the product formed will be Cu NO3 twice, and here also Cu NO3 twice. So what that means? Cu NO3 twice means what? Cu2 plus and NO3 minus. That means copper get dissolved in water, HNO3. zinc. ബാക്കി രണ്ടെണ്ണം zinc. Okay അല്ലേ, ZnNO3, ZnO3. Okay അല്ലേ. So that means copper get dissolved here. That is Cu2 plus aqueous plus NO3 minus aqueous. That means copper get dissolved in water HNO3. Okay അല്ലേ, Cu2 plus aqueous and NO3 minus aqueous the same way. Okay അല്ലേ. If it is concentrated, what is the product here is a 2NO2. What is the product formed here? It is a 2NO2. Okay, so copper is treated with concentrated HNO3 and zinc is reacted with concentrated HNO3. What is the product formed here? 2NO2. Okay, and the stoichiometry is also same, Cu plus 4HNO3 and Zn plus 4HNO3. Okay, so what is the product formed? ZnNO3 twice and 2NO2. CuNO3 twice and 2NO2. So 2H2. So it is a reaction for copper and zinc with concentrated HNO3. So they are reacted with diluted HNO3 formed, that is and so these are the product formed. Okay, so copper is reacted with the diluted HNO3. What is the product formed? 2NO. And zinc is reacted with the diluted HNO3. What is the product formed? N2O. And what is the stoichiometry? So stoichiometry here 3, 8 and 4, 10. So what is the stoichiometry? 3, 8 and 4, 10. So how many copper nitrate will be here? 3. How many Zn nitrate here will be? 4. And how many water will be here? Plus 5. How many water will be? Okay, so what are the reactions with the copper and zinc? Copper is reacted with the diluted HNO3. What are the product formed? Copper nitrate, 2NO and H2.
If I'm choosing wrong, I don't care at all.
Hello. Okay, give the reactions. If copper and zinc are reacted with concentrated HNO3, the products are same. So what is basically happened here is that copper get dissolved in HNO3, zinc get dissolved in HNO3. So what is important here? Oxides of nitrogen are formed here. This is the important thing. Okay, so if it is concentrated HNO3, what is the oxide, what is the gas evolved is 2NO2 and 2NO2. If it is diluted with the copper, gives 2NO. If it is diluted with the zinc, gives N2. Okay, it's a very important reaction of HNO3. That is reaction of HNO3 with copper and zinc. It's one of NCERT question. Okay. What is the most important is that what are the oxides of nitrogen are formed when copper and zinc are reacted with the diluted and concentrated HNO3. Here that is HNO3 can dissolve most of the metals except what? Noble metals. Okay, HNO3 can dissolve most of the metals except noble metals. HNO3 can dissolve most of the metals except noble metals. HNO3 can dissolve most of the metals except noble metals. Except noble metals. So what are the noble metals? Platinum, gold, etc. Okay, bracket platinum, gold. Okay, so which is the solution we are used to dissolve noble metals? Aqua regia. So what is the solution we are used to dissolve noble metals? Aqua regia. So what is aqua regia? It is a 3 part of HNO3 and 1 part of HCl mixture solution is called aqua regia. Okay, aqua regia bracket 3 part HNO3 plus aqua regia bracket 3 part HNO3 and 1 part HCl bracket close. Used to dissolve noble metals bracket, then used to dissolve noble metals. Okay, so which of the solution is used to dissolve noble metals? Aqua regia. Okay, and next one is brown ring test. Brown ring test. Brown ring test. Okay, brown ring test. Brown ring test. Okay, so what is brown ring test? Okay, test for nitrate solution. It is a test for NO3 minus 1 nitrate. Okay, so brown ring test, it is a test for what? Nitrate. So here we are taking the aqueous solution nitrate, aqueous solution of water nitrate, then adding water freshly prepared FeSO4 to the aqueous solution of nitrate. So here we can say that Fe2 plus are present. So Fe2 plus undergoes what? Oxidation. So it acts as what agent? Reducing agent. So what is oxidation state of nitrogen? NO3 minus 1 is plus 5. Okay, so Fe2 plus reduces what? 3 minus 1 into what? NO. And after that the Fe2 plus and NO are combined to give penta aqua nitrazonium. Penta aqua nitrazonium ion. This is the brown colored complex. In the presence of which medium? Acidic medium. So concentrated H2SO4 is poured along the sides of the tube. Along the sides of the tube, and there is a brown ring is observed at the interface of the solution and H2SO4. It indicates the presence of nitrate ion. So what do you mean by brown ring test? It is a test for nitrate ion in which freshly prepared FeSO4 is added to a aqueous solution of nitrate, then add concentrated H2SO4 along the sides of the tube. There is a brown ring color is observed at the interface of the solution and H2SO4. It indicates the presence of nitrate. The test is called brown ring test. So what is exactly happening here is that this Fe2 plus reduces what? NO3 minus into NO, then they combines to give what? The brown colored complex compound. So this test depends the ability of what? Fe2 plus to reduce what? Nitrate into what? NO. Okay, good. It is a test for nitrate ion. It is a test for nitrate ion. It is a test for nitrate ion. It is a test for nitrate ion, that is freshly prepared FeSO4, freshly prepared FeSO4, freshly prepared FeSO4 added to aqueous solution of nitrate, added to aqueous solution of nitrate, added to aqueous solution of nitrate, then add concentrated H2SO4 along the sides of the tube, then add concentrated H2SO4 along the sides of the tube, along the sides of the tube, along the sides of the tube. A brown ring is observed at the, a brown ring is observed at, a brown ring is observed at interface of nitrate solution and H2SO4, nitrate solution and H2SO4, nitrate solution and H2SO4. The test is called brown ring test. The test called brown ring test. The test called brown ring test. And next point, it depends the ability of Fe2 plus. It depends the ability of Fe2 plus. It depends the ability of Fe2 plus to reduce the nitrate ion, to reduce the nitrate ion, to reduce the nitrate ion into NO. NO. Okay, then Fe2 plus and NO, then Fe2 plus and NO, Fe2 plus and NO combines to give the, combines to give the, combines to give the brown colored complex compound, brown colored complex compound. Okay, FeH2O5 NO, NO2 plus. HNO3. Okay, preparation and properties of nitric acid. And there is a special hydride. Just a point special hydride of nitrogen. Special hydride of nitrogen is HN3. HN3, hydrozoic acid. HN3, hydrozoic acid. So what is the ion present here? The ion present here H plus and N3 minus 1. Which is the ion N3 minus 1? Azide. Okay. What is the normal hydride of nitrogen? NH3, ammonia. Okay, HNO3. Padi. Next. Allotropes of phosphorus. Dames. Allotrope phosphorus. Solunga sir, na padikire. Allotropes of phosphorus. Allotropes of phosphorus. Okay, so what are the allotropes of phosphorus? White, red, black. First put white. White phosphorus. white phosphorus is formed by heating water, phosphate rock with coke and sand at 1773 Kelvin, formed by heating phosphate rock. Formed by heating phosphate rock with coke and sand. Okay. So white phosphorus is the most reactive phosphorus based on red and black. Okay. So which is the most reactive phosphorus? Allotropes of phosphorus is white phosphorus. Why? So that is reactive than others due to. In case of red phosphorus and black phosphorus, it is a polymer of what? P4. Okay. So red phosphorus and black phosphorus are polymer of what? P4. So P4 tetrahedral units are polymerically connected to form what? Red phosphorus and black phosphorus. But in case of white phosphorus, there is what? Discreted P4 tetrahedral molecules. Discreted tetrahedral molecules. Discreted P4 tetrahedral molecules with what interactive force? Intermolecular force. But in case of black phosphorus and red phosphorus, there bonds and they will be the polymer of what? P4 tetrahedra. So reactive than others due to they contains discreted P4 tetrahedral molecules with intermolecular force. Okay. Reactive than others due to they contain discreted P4 tetrahedral molecules. They contains discreted P4 tetrahedral molecules. Discreted P4 tetrahedral molecules with weak van der Waals force. With weak van der Waals force. Van der Waals force. Weak van der Waals force. Okay. So that is 4 tetrahedra. Okay. P4 polar or non-polar? Polar or non-polar? Non-polar. So soluble in CS2 or water? Soluble in CS2, not in water. Not soluble in water. Not soluble in water but soluble in CS2. Not soluble in water but soluble in CS2. Not soluble in water but soluble in CS2. Okay. Poisonous. 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 Okay. Glows in dark. Glows in dark. Chemiluminescence. The property is called chemiluminescence. ഈ ഷവപ്പറമ്പിന് എന്താ പറയുക നിങ്ങൾ? ഷവപ്പറമ്പ് എന്താടി പറയാ നിങ്ങള്? തമിഴ് എന്താ പറയാ? ഗ്രേവിയാർഡ്. അതിന് എന്താ പറയാ തമിഴ്? എന്താ പറയാ? சுடுகாடு. அதானே சுடுகாடு. கரெக்டா, சுடுகாடு. அப்போ அங்கே நம்ம போன்ஸில் என்ன இருக்கு? phosphorus அல்ல. சுடுகாட்டில் என்ன இருக்கு? sand. அதே மாதிரி என்ன இருக்கு? கோக்கு. அப்ப அங்க என்ன ஃபார்ம் பண்ணிடுவா? நைட்ல அந்த ஒயிட் பாஸ்பரஸ் க்ளோஸ் பண்ண பே கிடையாது. அது என்ன? கெமிலூமினசன்ஸ். அது என்ன? கெமிலூமினஸ். பே கிடையாது. ஓகே, க்ளோஸ் இன் டார்க், கெமிலூமினசன்ஸ். இட் இஸ் டியூ டு த பிரசன்ஸ் ஆஃப் வாட்டர் ஒயிட் பாஸ்பரஸ். ஓகே, கெமிலூமினசன்ஸ், க்ளோஸ் இன் டார்க். Readily catches fire in air. Readily catches fire in air. Readily catches fire in air. So they cannot be exposed in water, air. Okay, so they are stored water. P4 plus 5O2 gives water, P4 water. Okay, P4 water. Stored under water. Readily catches fire in air. White phosphorus is in contact with the air, forms water, P4 water. So there will be fumes of water, P4 water. Okay, dissolves in NaOH. Dissolves in NaOH. pH 3 plus 3 NaH2PO2, sodium hypophosphate. So dissolving NaOH. So what is the preparation of phosphine? What is the preparation of phosphine? White phosphorus dissolves in NaOH, gives what? Phosphine. Okay. Dissolved in NaOH. So what is the preparation of white phosphorus? Heating phosphate rock with coke and sand at 1773 Kelvin. So it is reactive than others due to they contains what? Discreted P4 tetrahedral molecules and not soluble in water but soluble in CS2 due to its non-polar nature, and it is poisonous and glows in dark. It is called chemiluminescence. Readily catches in fire in air, that is P4. In the presence of air gives what? P4 atoms. So they are stored under water and they dissolves in NaOH, gives what? Phosphine and sodium hypophosphate. Okay, red phosphorus. Red phosphorus. Red phosphorus. Red phosphorus. So red phosphorus is formed from what? White phosphorus. Heating white phosphorus at 573 Kelvin in inert atmosphere for several days. In inert atmosphere, heating water white phosphorus for several days, they converted into what? Red phosphorus, formed by heating white phosphorus formed by heating white phosphorus at 573 Kelvin in an inert atmosphere for several days. So red phosphorus and black phosphorus are polymer of what? P4 tetrahedral. So they are polymer. Polymer of P4 tetrahedral. അല്ലേ? അപ്പോൾ റിയാക്ടിവിറ്റി ലോവർ ദാൻ വാട്ട്? വൈറ്റ്. ഹയർ ദാൻ വാട്ട്? ബ്ലാക്ക്. അല്ലേ? Polymeric form of P4 tetrahedra. Polymeric form of P4 tetrahedra. Polymeric form of P4 tetrahedra. Okay, so it is non-polar and polymer. അല്ലേ? നോൺ പോളാർ ആൻഡ് എന്താ മക്കളെ? പോളിമർ. അല്ലേ? സോ വാട്ട് അബൌട്ട് ദ സോളിബിലിറ്റി ഇൻ വാട്ടർ? Soluble or not soluble? Not soluble. What about the solubility in CS2? Not soluble due to polymeric nature. Due to polymeric nature. But not soluble in both H2O and CS2. Not soluble in both H2O and CS2. Not soluble in both H2O and CS2. Okay, not poisonous. അല്ലെങ്കിൽ നോൺ പോയ്സണസ്. നോൺ പോയ്സണസ്. നോട്ട് ഗ്ലോസ് ഇൻ ഡാർക്ക്. നോട്ട് ഗ്ലോസ് ഇൻ ഡാർക്ക്. നോട്ട് ഡിസോൾവ് ഇൻ NaOH. നോട്ട് ഡിസോൾവ് ഇൻ NaOH. നോട്ട് ഡിസോൾവ് ഇൻ NaOH. So white phosphorus, red phosphorus. Next one is black phosphorus. It has two types. It has two types. Black phosphorus. It has two types. So first one, phosphorus. Black phosphorus. It has two types. Black phosphorus. It has two types. First one is alpha black phosphorus. Okay, so alpha black phosphorus is formed from what? Red phosphorus. Heating red phosphorus at 803 Kelvin in a sealed tube gives what? Alpha black phosphorus. And the same way beta black phosphorus. So heating what? White phosphorus at 473 Kelvin under a high pressure. Under high pressure gives what? Beta black phosphorus. So what are the different types of black phosphorus? Alpha black and beta black. Alpha black is formed from red phosphorus. Beta black is formed from white phosphorus. So which is the most reactive one? White phosphorus. Which is the most not reactive one? Black. Okay. Alpha black phosphorus formed from heating red phosphorus at 803 Kelvin in a sealed tube. Beta black phosphorus is formed from a white phosphorus heating 473 Kelvin under a high pressure. Okay. So what are the allotropes of phosphorus? Are white phosphorus, red phosphorus, black phosphorus. What are the different types of black phosphorus? We have alpha black, beta black. Which is the most reactive one? white. Why? It contains discrete P4 tetrahedral molecules with weak van der Waals force, which shows chemiluminescence, which is not soluble in both CS2 and H2O. Red and black. Rendu soluble allallo. Red and black. Alla. Which shows അല്ലെങ്കിൽ അല്ല which dissolves in NaOH and give phosphine. White phosphorus. Okay അല്ലേ? Which soluble in CS2? White phosphorus. Trihalides of phosphorus അല്ലെങ്കിൽ simply PCl3 and PCl5. PCl3 and PCl5. PCl3 and PCl5 അല്ലേ? PCl3 and PCl5. So what is the structure of PCl3? Cl. What is the hybridization? sp3. What is the structure? Pyramidal അല്ലേ? What is the structure of PCl? So here 3 PCl, that is 3 PCl bonds are equal. 3 PCl bonds are equal. So but here we have 2 axial PCl bonds and 3 equatorial PCl bonds. Okay, which is more weaker, axial bonds or equatorial bonds? Axial bonds weaker than equatorial bonds. That means these axial bonds have a larger bond length than equatorial bonds. That means more suffers more repulsion from chlorine axial bonds. So which is most weak bond? Axial bond. So what happens? Therefore PCl5 hit, which bonds get break? Axial or equatorial? Axial. So it gives Cl2 plus what? PCl3. Okay. In PCl5 there we have 2 axial bonds and 3 equatorial bonds. Which is more weaker? The 2 axial PCl bonds are weaker than three PCl bonds are equal. sp3 hybridization, sp3 dehybridization, pyramidal structure and trigonal bipyramidal structure. There. PCl5 and PCl3. So PCl3 is formed 4 plus 4 PCl3. Okay, so how many 12, so that means 6Cl2. Okay, so PCl5 is formed. P5 plus Cl2 gives P4 plus Cl2 gives 4 PCl5. So how many chlorine is required? 20. So that is 10 Cl2. And here white phosphorus is SOCl2. That is thionyl chloride. It gives 4 PCl3 plus 4 SO2 plus 2 S2Cl2. So that means white phosphorus is reacted with the thionyl PCl3. And the same way white phosphorus is reacted with the sulfuryl chloride. That is SO2Cl2. Sulfuryl chloride gives what? 4 PCl5 plus 10 SO2. Okay, so white phosphorus is reacted with thionyl chloride gives what? PCl3, and white phosphorus is reacted with the sulfuryl chloride gives what? PCl5. Okay. Okay now. White phosphorus is reacted with the thionyl chloride gives PCl3, and white phosphorus is treated with the sulfuryl chloride gives PCl5. So basically you have to understand what you mean by thionyl chloride and what you mean by sulfuryl chloride. What is thionyl chloride? SOCl2. What is sulfuryl chloride? SO2Cl2. Okay. ഇതെന്താ എഴുതിച്ചേക്കണത്? 4Cl5 4 PCl5 4Cl5 കാണുക. 10 SO2Cl2. SO2 ബോഡിക്ക് നോക്കാതെ SO2Cl2 വരാ. 4 PCl5 4 PCl5 plus 10 SO2. അല്ലേ? സെറ്റ് അല്ലേ? നോക്കി മക്കളെ. So in case of PCl3, the 3 PCl bonds are equal. So they are breaking for similar for these 3 PCl bonds. But in case of PCl5, the 2 axial bonds are weaker and 3 equatorial bonds are stronger. So here first breaking is happening for which bonds? Axial bonds. So here PCl3 is reacted with the H2O. So 3 Cl bonds are breaking Cl plus so 3 OH combines with the P. So what is the product formed? POH thrice. It is an acid or a base? Acid. So what is 3 POH thrice? H3PO3. Okay, the same way PCl5 is reacted with the H2O. So how many HCl will be formed? How many HCl will be formed? Two axial bonds are weaker. First breaking for how much Cl? 2. Cl will be formed. Cl. So what is the valency here? 5. Up 3 Cl bonds. Okay, so here we have one oxygen. So what is the product formed? POCl3. Okay, this POCl3 we can again undergoes what? Hydrolysis. So how many Cl bonds undergoes breaking? 3. So Cl will be formed 3H required 6. 3 already. How many OH will be here? 3. 3 OH combines with the PO. 3 OH combines with the P. What is the product? So 3 OH combines with the PO. H3PO4. So what is the major product formed by PCl3 on hydrolysis? H3PO3. What is the product formed by hydrolysis of PCl5? So what is the first product formed? POCl. It again on hydrolysis to give what? H3PO4. And the same way. Look here. PCl3 is the organic compound contain OH. So here 3 Cl. So 3C2H5Cl plus H3PO3. So 3. Okay, 3Cl. And here 2H5OH. How the breaking? Okay, H with 1 Cl gives what? HCl. C2H5 with 1 Cl gives what? C2H5Cl. Oxygen combines here gives what? POCl3. Again this POCl3 reacted with what? C2H5OH. Complete breaking. So it gives what? 3C2H5Cl plus what? H3PO4. Okay, here also what is the product formed? H3PO3. Here also what is the product formed? H3PO. What is the first product formed? POCl3. Okay, and the same way reaction PCl3 plus CH3COH. PCl5 plus CH3COH. Okay, change. Okay, the organic compound contain OH bond. How the reaction works in case of PCl3 and in case of PCl5? வாய் திறந்து பேசு. சொல்லு. 6H2 எங்க 6H2? 3H2. ஓகே. 3H2 இதானா? அது சொன்ன போரு இல்லை எவ்வளோ நேரம் அங்கே அங்கே H3 ஐயோ ஆமே இல்லை எவ்வளோ நேரம் சொல்லுது அப்புறம் எனக்கு அந்த 3 புரிஞ்சது. போடு. Correct. The time 3. 1:05. Bloody time. நெக்ஸ்ட் ரியாக்ஷன் உங்களுக்கு போட்டது എന്തിനാണ് തലക്കടിക്കണേ? അവൾ നിലത്തെടുത്തിട്ടേ തലയ്ക്ക് കടിക്കുക. ഒരു മാനസിക രോഗിയുടെ മാതിരിയാ. നോക്കടോ, വയ്യാത്ത കുട്ടികളെ കളി കളിക്കുക. PCL 5 ആ AC ഇങ്ങനെ 17 തന്നെ ഇടണം നിർബന്ധം നിങ്ങൾക്ക്. ഒന്ന് കയറ്റിട്ടൂടെ? അതിൻ്റെ AC 17 ഇടണം. അത് കൊഞ്ചം 20-21 ഒക്കെ ആക്കലാം അല്ലേ? അപ്പോൾ കൊഞ്ചം കൂടി കറക്റ്റ് ആവൂലേ അല്ലേ? കൊടുടേ അതിൻ്റെ റിമോട്ട് എങ്കിൽ റിമോട്ട് എങ്കിൽ ടേക്ക് ദ റിമോട്ട്. ടേക്ക് ജസ്റ്റ് ഇൻക്രീസ് ദ ടെമ്പറേച്ചർ അല്ലേ? ഒരു 20 ഒക്കെ നൈസായിരിക്കും അല്ലേ? 17 കുറച്ച് കൂടുതലല്ലേ? ഓക്കെ സെറ്റ്. ഓ, അവനാ കുളിര് നല്ല പിടിച്ചിട്ട് അല്ലേ? 17 20 ആക്കാൻ വലിയ മൂടില്ല. PCL 5 അല്ലേ? जी അല്ലേ? എന്തായി കറക്റ്റല്ലടാ? OH ബോണ്ട് 3. അപ്പോൾ 3 CH3 CO പ്ലസ് H3 PO3. ഹിയർ COCl plus HCl plus POCl3 അല്ലേ? again POCl3 plus CH3 COOH 3 gives a 3 CH3 COCl plus H3 PO4. ഓക്കെ അല്ലേ? PCl3 ഒരു വൈറ്റ് വാക്സി ലിക്വിഡ് കൊടുക്കുക. വാക്സി ലിക്വിഡ്. PCl5 വൈറ്റ് യെല്ലോയിഷ് പൗഡർ അല്ലെങ്കിൽ യെല്ലോയിഷ് വൈറ്റ് പൗഡർ. ഈ വൈറ്റിൽ വന്നിങ്ങനെ ചിന്ന യെല്ലോ വരില്ലേ, വൈറ്റിൽ വന്ന് ചിന്ന യെല്ലോ അല്ലേ, அந்த மாதிரி ഒരു പൊടി പൗഡർ അല്ലേ? സാർ കിട്ടിയ ഓക്സോ ആസിഡ്സ് ഓക്സോ ആസിഡ്സ് ഓഫ് ഫോസ്ഫറസ്. ഓക്സോ ആസിഡ്സ് ഓഫ് ഫോസ്ഫറസ്. Oxo acids of phosphorus. So what are the oxo acids of phosphorus? H3PO2, H3PO3, H3PO4, H4P2O5, H4P2O6, H4P2O7 and HPO3 n times. So it is a hyporous acid. So what is H3PO3? Orthophosphorus acid. So what is H3PO4? Orthophosphorus acid. So what is H4PO5? Pyrophosphorus acid. Okay. So what are hypophosphorus acid? So what is H3PO3 and H3PO4? Orthophosphorus, orthophosphoric. Up next one, new one, pyrophosphorus. So what is next? Hypophosphoric acid. So what is next one? Pyrophosphoric acid. Okay. So what is H3PO3? For orthophosphorus and orthophosphoric. So H3PO2 is a hypophosphorus. Next one is a pyrophosphorus. Next one is a hypophosphoric. Next one is a pyrophosphoric. Okay. Metaphoric acid. Good. Hyporus, orthorus, orthoric, pyrorus, hyporic, pyroric. അല്ലേ? ഈ ബ്ലോക്ക് ആയപ്പോൾ ടൈമും പോണില്ലേ അല്ലേ? Hyporus അല്ല, ഹൈപ്പോറസ്, ഓർത്തോറസ്, ഓർത്തോറിക്, പൈറോറസ്, ഹൈപ്പോറിക്, പൈറോറിക് അല്ലേ? റസ് റിക്ക്, റസ് റിക്ക്, റസ് റിക്ക് അല്ലേ? ഹൈപ്പോ, ഓർത്തോ, ഓർത്തോ, പൈറോ, ഹൈപ്പോ, റിപ്പോ അല്ലേ? എൻ്റെ okay, H3PO2, H3PO3, H3PO4, H4P2O5, H4P2O6, H4P2O7 and HPO3 n times. Metaphosphoric acid. മുടിയിട്ടും ഓക്കെ അല്ലേ? ഓക്കെ. Okay, HPO2, H3PO3, H3PO4. So phosphorus. All these are central atoms are phosphorus. Central atoms are phosphorus. So all these are oxo acids of phosphorus. So they should contain what? An oxo group. Oxo. First in the mandal oxide. So what is the valency of phosphorus? 5. Okay, 5. Okay, how many hydrogen? 3. Hydrogen, 1 hydrogen. Okay, how many oxygen is remaining? 1 OH. Hydrogen. How many oxygen remaining? 2. 1 OH, 2 OH. How many hydrogen or oxygen is remaining? 3. So it is monobasic or dibasic? Monobasic. Monobasic. So what is equivalent weight is equal to? Equivalent weight is equal to molar mass divided by 1. Okay. So what is the dibasic? What is by 2? What is it? Okay, so here we have 1 OH, so it is monobasic acid. Here we have a 2 OH, it is a basic acid. Here we have a 3 OH, so here it is a tribasic acid. So what is equivalent weight of an acid is equal to molar mass divided by basicity, number of H plus displaced from one molecule. Okay, next H4P5, 2P with mandal oxygen. Okay, how many hydrogen? 4. So 2 for this phosphorus and 2 for this phosphorus. How many oxygen is remaining? 3. So 1 4 here, 1 4 here, 1 4 common. Okay, H4P2O6. How many for? 2. Mandal oxygen. Okay, how many hydrogen? 4. 2 for this phosphorus. How many oxygen remaining? 4. 2 for this phosphorus. Okay, H4P2O7. Phosphorus, mandal oxygen. How many hydrogen? 4. 2 for this phosphorus, 2 for this phosphorus. How many oxygen is remaining? 5. 2 for this phosphorus, 2 for this phosphorus, 1 for both. Okay, good. എന്തുകൊണ്ടല്ലോ എന്തോ ഇല്ലേ ഏതോ ഇருக்கு ഇപ്പൊ ടൈം എന്നാச்சு? ആ 3:35 ആയോ? നമുക്ക് 3:45 ആകുമ്പോഴേക്ക് എടുക്കാം അല്ലേ? 10 minutes 3 കറക്റ്റ് അല്ലേ? 4 o'clock ഒരു അല്ലേ നൈസ് ടൈമിങ്. ഓക്കെ, എന്ത് കൂടെ ചെയ്യുന്നവര് 10 minutes കൂടി കഴിഞ്ഞാൽ 3:45. Only 10 minutes. തിങ്ക് പണ്ട് പാറ് അല്ലേ? Okay, so these are the oxo acids of phosphorus. So what is the oxidation state here? What is the oxidation state? -2, -1, +1, +1. അപ്പോൾ എത്ര വരിക? +1 അല്ലേ? -2, -1, -1, +1 എത്ര വരിക? +2 +3 അല്ലടാ? ഇത് എത്രയാ? ഇത് എത്രയാ? -2. ഇത് എത്രയാ? -1. ഇത് എത്രയാ? -1. ഇത് എത്രയാ? +1. അപ്പോൾ ഇയാൾക്ക് എത്ര വരിക? +3. ഓക്കെ അല്ലേ? അതേപോലെ ഇത് എത്രയാ? -2, -1, -1, -1. അപ്പോൾ ഇയാള് +5. ഇയാള് -2, -1, +1. ഇത് ഓച്ചാണല്ലോ. -1 അല്ല, ഓക്സിജൻ വിത്ത് 2 ബോണ്ട് ആണെങ്കിൽ -2, വിത്ത് 1 ബോണ്ട് -1. അപ്പോൾ വാട്ട് ഈസ് എ ബോണ്ട്? -2, -1, -1, -4 +3. ഓക്കെ അല്ലേ? ഹിയർ -2, -1, -1 ഇത് 0 അല്ലേ? സോ വാട്ട് ഈസ് ഓക്സിഡേഷൻ സ്റ്റേറ്റ്? +4. ഓക്കെ അല്ലേ? -2, -1, -1, -1 +5. ഓക്കെ അല്ലേ? ഓക്സിഡേഷൻ സ്റ്റേറ്റ്. Phosphine. അപ്പോൾ നൈട്രജൻ NH3, HNO3, allotropes of phosphorus, PCl3 and PCl5, oxo acids of phosphorus and phosphine. Okay, so these are the compounds of nitrogen family. N2 preparation properties and uses, NH3 preparation properties and uses, HNO3 preparation properties and uses, allotropes of phosphorus, white, black, red, PCl3 and PCl5, oxo acids of phosphorus, phosphine. Okay, phosphine preparation. 5 sp. 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 5 phosphide treated with phosphides treated with HCl or H2. Okay, so here 2P is converted into what? Converted into water. pH3. Okay, so how many OH will be here? 6. 6. So how many calcium is here? 3. 1 calcium combines with 2 OH. So what is the product formed here? 3CaOH twice. Plus how many H is used? 6. So how many chlorine is used? 6Cl. How many calcium? 3 calcium. So what is the product formed will be 3CaCl2. Okay, put it. So what is the preparation of phosphine? White phosphorus dissolves in NaOH. White phosphorus dissolves in NaOH. So what is the equation? P4 plus 2 gives what? NaH2PO2. So what are the preparations of phosphine? Phosphides are treated with H2O or HCl. Next one is white phosphorus is dissolves in NaOH. So what is the important equation is white phosphorus dissolves in NaOH. Comes in 2 portions of P block elements. Okay. So properties. Rotten fish smell gas. Rotten fish smell. Bad smell of fish. Rotten fish smell gas. Acidic or basic? Acidic or basic? Acidic basic. Which family? Which family? Nitrogen family. NH3, BH3, SH3, SBH3, BH3 are basic in nature due to the presence of lone pair of electrons. Basic in nature due to the presence of lone pair of electrons. What is the product formed by NH3 treated with HCl? NH3 treated with HCl. NH4Cl. What is the name? So what will be the product formed when PH3 treated with HCl? PH4Cl. What is the name? Phosphorium chloride. So it reacted with the acids gives corresponding phosphorium compounds. Reacted with the acids gives corresponding phosphorium compounds. Phosphorium bromide, like our ammonium chloride. Ammonium chloride, ammonium bromide. Okay അല്ലേ? Pure phosphine is non-inflammable. Pure phosphine is non-inflammable. Pure phosphine non-inflammable. Pure phosphine is non-inflammable. Pure phosphine is non-inflammable. Non-inflammable. But impure phosphine is inflammable. But impure phosphine is inflammable due to the presence of P2H4, P4, etc. P2O3, P2, etc. Due to the presence of P2O3, P2O5, P2O5, P4, etc. Okay, so impure phosphine, impure pH3. So impure pH3 contains what? pH3 plus P4 plus P2O5. Okay, when it treated with H, HI, so HI is an acid or a base? Acid. So it combines with what? Base. So this product formed will be PH4I. PH4I. So this PH3 comes out from the impure phosphine and it treated with KOH. Treated with what? KOH. So what is the product? K and I. What is the product formed will be Ki. OH and H. What is the product formed will be H2. And what is the product formed here? PH3. So it will be the pure phosphine. So they can be purified by treating the impure phosphine with the HI, then followed by KOH. Okay, good. Can be purified by. It can be purified by treating impure phosphine with the HI followed by KOH. Followed by KOH. Followed by KOH. Okay, that is impure phosphine pH3 plus P4 plus P2O5 reacted with HI gives PH4I. Now, impure phosphine when it contact with the air, what happens? Inflammable. Inflammable. P2O5, P4O10. P4 gives what? P4O10. So that gives the fumes of P4O10. So what is the uses of phosphine? They are used in screens. They are used in smoke screens in war. Smoke screens in war. Inenda paraya? Poga, smoke. Smoke. PUBG. What are you Original war. Puga marra. Inda malathu paraya? Chetamil paraya? Puga. Puge marai. Warle. Puge marai. That is some smoke screens in war. Impure phosphine tissue. Full puge mar. In home signal. In home signal Holmes signal. In Holmes signal. Okay. Holmes signal. Okay, mokla ship. Small ship da. Don't expect big ship. Small ship. Okay, allo. Appo എന്താ മക്കളെ ഇവിടെ വലിയൊരു കുന്ന് അല്ലേ? ദാറ്റ് മീൻസ് വേറെ ഷിപ്പ് അല്ലേ? ഓക്കെ ആണല്ലോ. സോ ദിസ് ഷിപ്പ് ഷുഡ് ഷോസ് എന്താണ് മക്കളെ? എ സിഗ്നൽ ഫോർ ദിസ് ഷിപ്പ്. സോ വാട്ട് ദേ ആർ ഡൂയിങ് ഇസ് ദാറ്റ് ദ കണ്ടെയ്നേഴ്സ് കണ്ടെയ്നിങ് calcium carbide and calcium cyanamide pieced and thrown to the sea. So what happens? H2O comes. So they gives what? That is evolving gases. There is a gases. Calcium carbide, calcium phosphide and Ca3P2. Calcium phosphide. So what they forms a PH3. So this PH3 will be impure phosphine, and there is a acetylene gas also. PH3 comes in contact with water, air. So it catches fire in air. Thus fire acetylene gas. So it serve as a signal. Okay. So basically which burn? Acetylene gas. Okay. Starting burn arana impure phosphine. So this signal it serve as a signal. The signal is called Holmes signal. Very simple. That is the containers containing calcium carbide and phosphide. Containers containing calcium carbide and calcium phosphide. Pieced and thrown to the sea. Pieced and thrown to sea. The evolving gases burn and serve as a signal. The evolving gas burn and serve as a signal. Evolving gas burn and serve as a signal. Okay. Nitrogen family completed. Happy. Padinga. അങ്ങനെ നൈട്രജൻ ഫാമിലി. ഇനി ഓക്സിജൻ ഫാമിലി, ഹാലജൻസ്, ഇനേർട്ട് ഗ്യാസ് അല്ലേ? ഓക്സിജൻ ഫാമിലി നെക്സ്റ്റ് അല്ലേ? ഹാലജൻസ് നെക്സ്റ്റ് അല്ലേ? ഇനേർട്ട് ഗ്യാസ് നെക്സ്റ്റ് അല്ലേ? ആളൊക്കെ വേണം. നോക്ക് അല്ലേ? നൈട്രജൻ ഫാമിലി അല്ലേ? അറ്റോമിക് റേഡിയസ്, ഇലക്ട്രോണിക് activity, അയണൈസേഷൻ എനർജി, മെറ്റാലിക് ക്യാരക്ടർ, മെൽറ്റിംഗ് പോയിന്റ്, അലോട്രോപ്പിസം അല്ലേ? പിന്നെ റിയാക്ഷൻ, ഓക്സിഡേഷൻ സ്റ്റേറ്റ്, റിയാക്ഷൻ വിത്ത് ഹൈഡ്രജൻ, റിയാക്ഷൻ വിത്ത് ഓക്സിജൻ, റിയാക്ഷൻ വിത്ത് ഹാലജൻ. ഇമ്പോർട്ടൻറ്റ് കോമ്പൗണ്ട്സ് N2 പ്രിപ്പറേഷൻ പ്രോപ്പർട്ടി, അമോണിയ പ്രിപ്പറേഷൻ പ്രോപ്പർട്ടി, HNO3 പ്രിപ്പറേഷൻ പ്രോപ്പർട്ടി, അലോട്രോപ്സ് ഓഫ് ഫോസ്ഫറസ് അല്ല? വൈറ്റ്, ബ്ലാക്ക്, റെഡ്. പിന്നെ PCl3 ആൻഡ് PCl5, ഓക്സോ ആസിഡ്സ് ഓഫ് ഫോസ്ഫറസ് ആൻഡ് their corresponding structure. Then last phosphine property preparation അല്ലേ? വെരി സിമ്പിൾ അല്ലേ? സിമ്പിളാ സാധനം സിമ്പിളാ അല്ലേ? പി ബ്ലോക്ക് എലമെന്റ്സ് இவ்வளோ വലിയ சாப்டர் இல்ல, அந்த மாதிரி ஃபீல் பண்றல, அந்த மாதிரி ஃபீலிங் இல்லையா? இல்ல சார், இல்ல ഞങ്ങൾക്ക് அந்த மாதிரி இல்ல. നീറ്റുക്ക് എല്ലാ ചാപ്റ്ററും இருக்கும் അല്ലേ? നീറ്റുക്ക് എല്ലാ ചാപ്റ്ററും എടുക്കും. பிக் கேம் അല്ലേ? അപ്പോൾ എന്തായാലും എന്താണ്, பி ப்ளாக் அந்த சாப்டர் பெரியதாக இருக்குது, இந்த சாப்டர் பெரியதாக இருக்குது, அந்த மாதிரி ஒன்றும் சொல்லாதுங்க. உங்களுக்கு எல்லா சாப்டரும் தெரிஞ்சுதாகணும் അല്ലേ? പി ബ്ലോക്ക്, കാർബോക്സിലിക് ആസിഡ്, ഹൈഡ്രോ കാർബൺസ്, ബേസിക് ഓർഗാനിക് കെമിസ്ട്രി, ഇഷ്ടംപോലെ അല്ലേ? കുറേ സാധനങ്ങളുണ്ട്, ഒക്കെ പഠിക്കണം. നീറ്റ് MBBS അല്ലേ? നൈസല്ലേ? സാധനം കിട്ടൂലേ? പിന്നെ കഴിച്ചിട്ടുള്ള സാധനം എന്താ പറയുക? സിസ്കോബ എന്നാ ഇങ്ങനെ കളിക്കുക.